बहुत अच्छा। थोड़ा पानी पिलाई थे ग्लास ठंडा मस्त। वो है भाई कौन है? ऊपर ऊपर खुद मैं कर लूँ।
Good afternoon. यार भी कैसे क्या ट्यूशन எனக்கு கேட்ட மாதிரி தெரியல. Good afternoon.
Good afternoon, sir. Good afternoon.
Good afternoon to all distinguished members of Institute of Indian Foundry Man, NCSD mentors, industry professionals, participants, and my dear friends. It is my great pleasure to extend warm welcome to everyone for joining this NCSD virtual program on unlocking the lean potential in found industry. This webinar reflects the commitment of National Center for Skill Development towards enhancing knowledge, operational excellence, and continuous improvement within the Indian foundry sector. We are privileged to have with us today an accomplished trainer and industrial expert, Mr. Anand Des, founder and CEO of Pebbles Management Services. With more than a decade of rich experience in lean manufacturing, problem solving, design thinking, TPM, Kaizen, 5S, Six Sigma, and soft skill development, he has successfully guided numerous reputed organizations, including Royal Enfield, Saint-Gobain, TVS Group, Anonymity, Sanofi, and many others. Mr. Anand brings a unique combination of technical expertise and behavioral skill development, helping organizations to improve productivity, reduce waste, strengthen teamwork, and create a culture of continuous improvement. His practical exposure in implementing lean tools such as VSM, SMED, SPC, FMEA, TPM, and structural problem solving methodologies makes him an ideal speaker for today's session. In today's competitive manufacturing environment, lean practices are no longer optional. They are essential for achieving operational excellence, quality enhancement, cost optimization, and customer satisfaction. I am confident that today's webinar will provide valuable insights and practical learning for all participants. On behalf of NCSD and the Institute of Indian Foundryman, I sincerely thank our mentor, Mr. V. Narasimhan, Chairman Sir, Mr. K. Dayalan, Co-Chairman, Mr. C. Satyamurthy, and all organizing members for making this program possible. I also extend my heartfelt gratitude to all participants for taking time to join this knowledge sharing session. Once again, I am warm welcome our esteemed speaker, Mr. Anand Des, and all attendees. Wishing you an engaging and insightful learning experience. Thank you. Mr. Anand, sir, you can start your program, sir.
Good afternoon, everyone. This is Anand from Tables Management Services. I'm very happy to be here to present a webinar in a topic of unlocking the lean potential in manufacturing sector. And good afternoon to my all dignitaries and participants once again. So thanks for the opportunity provided by IIF, Mr. Sandil Kumar and Mr. Gopal sir. So let's go to the topic. And before starting the topic, I would like to say one quote like, foundries are not becoming profitable by working harder. Foundries are becoming profitable when they are eliminating the wastages in a systematical way. So in such a way, so how we can eliminate the wastages in terms of lean, how we can improve our workplaces. So that is what we are going to see today. So this is our program agenda. So we are going to see about the 7 wastages and what they cost in foundries and how it is affecting your day-to-day work routine. And then lean pillars and tools of real world applications with the case studies and proven ROI, and implementing the how the lean manufacturing concepts, and as well as a digital lean and industry 4.0 integration to the foundry industry. Yeah. So as I told you, so foundries are becoming profitable by eliminating the wastages in an effective way. So they can able to increase the profitability 15 to 40% without major capital investments. So this will be structured like for executives to understand about the concept of lean and unhidden truth of lean implementations. Yeah. So I want to be very interactive. So I would request participants to share your views, insights in that. So yeah. So as you are being working in the foundry industry, what is your biggest challenge today? I request participants to be interactive. What is your biggest challenges today when if you are facing in foundry industry?
Skill.
Yeah, skill set. Yes. I think we have only one participant here. Come on, guys. So let's make the session is very interactive and fun filled. So what is your biggest challenges you're facing today?
Getting manpower is an issue because of the.
Yeah, yes. Yeah, yes. Because
everybody wants to go for a white collar job.
Yeah.
Then in that foundry is not this one.
Undoubtedly, sir. Undoubtedly, it's true. Yeah. Then what else?
We have to improve the environment. The working environment we have to work. That's a big challenge.
Yes. Yes.
If we improve the environment, we can get a manpower. The skill is different. And again, skill we can do it by de-skilling activity of this any machinery. That also. First of all, we have to attract the people to the foundry industry to improve to improving our environment. First to foundry environment.
Yes, exactly. Then what else?
Cost of manufacturing.
Pardon, sir, I didn't get you.
Cost of manufacturing.
Yeah, yes, that is what he also meant. So the environment of foundry industry.
Cost of manufacturing, I am saying.
What is that?
Cost of
manufacturing.
Cost of manufacturing. Yeah, exactly. So now you came into the pipeline. Yes. Cost of manufacturing. So this is the industry reality. So which we are facing, like energy cost is increasing simultaneously, labor shortages, global competition, OEM pressure on the pricings, margin erosions and delivery expectations, and skill level of the employees, environment of the foundry industry. So, and natural calamities and war. So these are the things are directly affecting the industries, foundry industry. So how we can overcome this? By implementing a lean concept in an effective way, by reducing the wastages in the foundry industry. So in the foundry industry today, the pressure is very much real and impactable. So as per the article, World Foundry Organization in 2024, they published. So 68% of foundries operating a below peak efficiency. You'll not believing me. 68% of foundries operating a below peak efficiency. But the global foundry market size, estimation size is 4.2 trillion. And then they are doing average profit margin loss to the production wastages alone 22%. And then ROI achieved by the top lean foundries in 3.1x. So this is the World Foundry Organization article as published. So this is the real data. So how we can implement a lean concept? So before that, we should know what is lean. Lean, which is nothing but to eliminating the wastages and adding the value to the product or any process, that is called lean. So we could say that is value added process. So eliminating the waste, which is nothing but we could say another terminology called NVA, non-value added activities. Non-value added activity means the person, they are doing an activity, but which will not add the value to the product or any process. That is called NVA. So for a better understanding, I'll play a video of a difference between value added and non-value added activity. So I hope you all have, the screen is visible, the video screen is visible. Is it visible?
Yes.
Yeah. So let me play this video, and wherever the red color arrow mark is indicating the non-value added activity, and green color is indicating the value added activity of this process. So So guys, tell me about your view on this video. So what are the things she have done it as an NVA activity? You can see the number of NVA activities she have done, around 29 activities. This video lapse time around 1 minute. So in 1 minute, she have done only 4 seconds of value added activity. I mean the spot weld, 4 spot welds, and rest of all the motions, movements, and everything is considered as NVA. Because so when the manpower or machine is transforming a product, one physical shape into another physical shape, that is called value added process. So if the physically or chemically, if the product is not changing, that is called NVA, that is called non-value added activity. So according to the terminologies of value added and non-value added, so what is your view on this video? So, and how we can eliminate this non-value added activity? Guys, the ball is from your side. It is your side. So you please tell me how to reduce this non-value added activity. Participants or can able to see my hello? Are you there?
It's unwanted
Yeah.
activities, movement.
Yeah, yes. So how we can eliminate this 29 steps, 29 non-value added activities? By implementing an effective way of 5S. Okay, so this non-value added activity, which is coming under a motion waste, we will see what is motion waste also. So I'll play this video again. You just see how the motion she is doing, how she is doing a motion waste. So she turned around, she took the bin and she placed in front of the machine, and she placed the part on the machine, and she is clamping also. So spot weld got finished. So after that, she is going to take a part from the jig, and by ejecting the pre-pins. So how to avoid this NVA is to allotting the frequently using items or parts or bins nearby the working place without turnaround, without climbing, without bending down. So that is called effective place allotment. If we provide a proper place allotment, we could say that is a golden area for the operator. So if we can do it in such a way, by proper space allotment, we can reduce the cycle time of this process. For example, by reducing the motion waste 29 steps into 20 steps in a first improvement, that is also an improvement. For example, in a 1 minute, you have reduced around a 10-second, means that is also an improvement. For one part, if you are reducing a 10 part, means in a 8-hour shift, so how you can reduce the whole time? So the output would be numerous. For example, 30 to 40 minutes per shift. So time that we can save. So this is for an example. So in such a way, so this is the lean concept. In such a way, we have to implement this lean concepts in each and every worker stable as well as the process also. I hope you understand from this concept what is value added and what is non-value added, and how we can eliminate the non-value added, or how we can convert the non-value added activity into value added activity. Any doubts, any clarification do you require? Dear participants, can you please respond? Did you have any doubts, or do you need any clarification?
No.
Yeah.
If you can share any of the example after the correction of lean, it will be better to understand.
Yeah, sure. Yeah. So there are 7 lean wastages are available in the product in all the manufacturing areas. So we could call as TIM wood. So TIM wood, which is nothing but transportation, inventory, motion waste, waiting waste, overproduction waste, over processing waste, and defect waste. And nowadays the people are called 8 wastages. The last waste is 8th waste is skill waste. Okay, so the transportation waste, which means moving a part or material from one place to another place. Why we are calling transportation is waste means, so simply transferring or moving a part from one place to another place. If there is any changes in the product physically or chemically, there is no, right? So that is why we call transportation is a waste. So have given an example, moving molten metal across the unplanned route. If we have the planned routes, so there will be not unnecessary transportation between the stations or between the operator or processes. So then second one is inventory. So inventory, which is nothing but a raw sand or scrap piling up between the operators. For example, inventory can build up because of raw material or work in process or finished goods. For example, if one operator, they are doing a process, okay, so if the cycle time is not balanced, what will happen is first operator, they will finish the process in a fast, but once he moved to the next operator, there will be a possibility to build up the WIP inventory because of second operator cycle time is high. So this is also one of the reason to build up a inventory between the operations. And third one is motion. That is what we have discussed, and we have seen the practical video. So the workers walking excess distance to fetch the tools, to fetch the parts, and to search the part, that is called motion waste. And the fourth one is waiting waste. Either the man is waiting for a part, or the part is waiting for a machine. If in case a machine got breakdown, so the part is also waiting, the manpower is also waiting. So this is called waiting waste. For an example, furnaces in an idle way, while charging, mix is prepared. Okay, so what will happen is there might be a waiting waste might happen. And fifth one is overproduction. Beyond the expectation or demand, the people are producing the parts or production means, that is called overproduction. And the sixth one is over processing. For example, multiple time inspection, multiple time redundant operation, that is called over processing. For example, polishing or brushing or grinding process beyond the spec value, RA value means that is also a over processing, because during the over processing, there might not be a changes, value added changes. So then seventh waste is defect wastages. So defect, we know very well about the defects like porosity, shrinkage, misrun, scraps and reworks. That is all coming under the defect wastages, because in defect waste, there is a happening of physical changes, but the customer, they are not paying for our fault, right? So the customers, they are paying for what the product they are getting in a quality way, like as per the standard spec. That is what the customers are paying. So the customer, they are not paying for our internal fault, our internal mistakes and reworks, rejections, scraps and everything. So this is what the over layout above the 7 wastages. So which is called TIM mode. And then eighth waste is called skill waste. Underutilized skill. For example, a one person, he is well versed in the production department, but he is working in some other quality department or admin area, means so there might not be a skill utilization. So that is called skill waste. And as well as the skill waste, we could say in other way, the skill waste from the down level, if they are giving any valuable suggestion, we have to take it from the workers level suggestions also. So if we simply ignore it, that is also called a skill waste, right? I hope you got the clear outline of this 8 wastages. So we will dig deeper into what is 8 waste in a practical way. So transportation, as I told you, unnecessary movement of materials, molds, casting, sand, tools or equipment or any other things. So it is called a transportation waste. Crane movement, forklift movement, manpower movement, fuel or power movement. So that is also a transportation waste. Example, a foundry producing a pump housing. The process flow, the example process flow would be first sand plantation, molding section, core shop, pouring process, cooling process, fettling process, shot blasting, and final one is inspection. So the departments are locating a far away from each department. The problem is casting travels 480 meters before completion. User also, crane usages, they are using a 11 times for one product, and there is a possibility to waiting time is between the transportation. So this is a problem. So as we know about the lean concept, we will tell people to organize or optimize the layout of the process. So layout, which is nothing but to arranging the process in a flow way. For example, sandblasting is very adjacent to the next department, means that is also a effective optimization of layout. And cellular manufacturing, like group cell manufacturing. So if we make our work process in a cellular way, like group 2 or 3 people are working like a cell, means so that will also reduce the transportation of materials. And then point of use storage, all the tools or materials or parts should be easily accessible to the workers. That is all. That is called point of use storage. For that, taking a product or tools or a part, he or she shouldn't climb or bend down and move away to take a part. It shouldn't happen. So that is called point of use storage. We could say golden area. So if the operator is standing in front of the machine, he reached out the hands. So all the items should be on the hand accessible area. That is called a point of use storage. And if there is a possibility to implement a gravity flow or conveyor flow to reduce the transportation. That is also we can reduce the power saving, manpower movements, manpower also. So the parameter, the material travel distance, if we implement all this lean solution to that problem area, we could get material travel distance 480 meter to 140 meter. So by reducing this travel distance, we can save crane fuel cost, waiting time, manpower waiting time, and everything. Crane usages 11 times to 4 times. Productivity somehow some percentage to 18 percentage. Damages or rejections, it may reduce. So this is the concept of a transportation waste. So next one is, so this is called a transportation waste. You can see here. So I think the images got misplaced. So you can see here the receiving raw material parts have been stored in one place. So it has been moved to the production and WAP storage, and you can see the red color arrow mark. So the WAP storage next to the packing. So like it travels a more, the distance is more. From packing department to finished good flow also, there is no physical or chemical changes. But if you take a raw material storage, it is moving from raw material storage to production, right? So what will happen? It is very much mandatory, but there is no physical changes or chemical changes, but that is mandatory. It is in the nominal distance. Then after the production, it will be stored as a WAP storage. And it is also a mandatory to store a part after the production. Then from the WAP storage, it is moving to the packing department. There is no physical or chemical changes, as well as it will take a huge distance. Then likewise, packing department to finished goods. Then what would be the improved flow is packing department. If we shift or replace it to nearby the WAP storage, so what will happen? So the movement from WAP to packing department will be reduced. So by reducing this distance, as I said, we can reduce the time of employee, transportation time, and fuel time of the transportation machine. So this is the advantages of eliminating the transportation waste. Now we can see the inventory waste, excess raw material, WAP, sand, cores, finished goods, or spare parts. If it is storing in a one place, that is called a inventory waste. So let me see an example. A foundry stores a 45 days of raw material, 20 days of WAP, and 30 days of finished goods. The problem is a capital investment is blocked in such a way, and then material is getting rusted, because if we store a material in an open way, so there might be a possibility to getting rusted, and then pattern it will get mixed up, and space congestion also, and poor visibility, which is the part, and there might not be a clarity when we stored as a WAP in a production area as well as the store. So the hidden cost is inventory. If we are storing a part or material as an inventory, it will be like a capital cost. And then more forklift operation is required and more space is required, because nowadays a lot of companies, they are charging management that we are running out of the space. So, and then material deterioration, and then cash flow pressure. According to the MSME, so they have to reduce the inventory cost. So to improve the cash flow. So this is an example. So for this problem, we will suggest a pull system. For example, based on the customer demand only, the purchasing department, they will raise a request to the suppliers, to get a parts. And then FIFO system, first in, first out system. So by implementing a FIFO system, so we can reduce the rusting of the parts. Then Kanban system. So if we implement a Kanban system, so if no one tells, automatically, if the material count is getting delayed, so based on the Kanban card, so they will order a required quantity. So it is like a auto replenishment, like not complete automation. It is a semi automation or pull system. And then last one is daily production planning. To reduce the excess batch production, we can reduce the inventory. So you can see here inventory before it was a 95. After all this implementation, so it may reduce up to 42 days, and space usage also it will reduce from 100 to 65%. So this is for an understanding. And then a motion waste. I think someone have asked about what is the motion waste and example. So this is an example. So unnecessary movement of people, like up and down movements, left, right movements, searching for a tools. The people is searching for a tools. People is searching for a part because of not clarity about the which part it is stored as a WAP or an input. So this is called motion waste. And waiting waste. Ideal time, we could say a waiting waste. Man is waiting for a machine, or machine is waiting for a man or part because of shortage of the material, and material is waiting for a manpower or machine breakdown. So this is called waiting waste. So the situation is melting furnace is ready, but mold is not ready. What will happen is furnace waits around 40 minutes per heat. Okay, so what will be the impact because of the situation? Energy waste might be happened, reducing the throughput, overtime will increase, and delivery might be delayed. So this is the waiting waste. So what is the suggestion for this waiting waste is line balancing. So synchronizing the mold and melting parts. So line balancing, which is nothing but to reducing the or equaling the cycle time between the operators or process. So that is called line balancing. So I'll give you an example. First operator cycle time is 3 minutes. Second operator cycle time is 6 minutes. Third operator cycle time is again 3 minutes. What will happen is the first operator, he will finish a part within a 3 minute. But the second operator, he will take 6 minutes to complete a one product. What will happen is in a second operator, there might be a chances of building the WAP process, and before first operator or third operator, they may get idle. So what happens is obviously your overall equipment efficiency will be getting lesser. Yeah. So if we implement all this suggestions or as a solution for that problem, what will happen is furnace idle time will be getting reduced from 40 minutes to 8 minutes. Production capacity will be increased, and energy loss also will be getting decreased. And by following the proper TPM, like if we implement a TPM, there might not be a breakdown maintenance, surprise breakdown maintenance. And the 6 core lean methodology for Foundry tools is 5S. So 5S, if we say 5S to any employee or worker, they will see 5S as a cleaning tool. But what is 5S is? It is nothing but to cultural development tool. 5S is a cultural development tool. If we implement a 5S in an effective way in a production area, what will happen is there might not be a unwanted items or unwanted parts accumulation on the workplace, and there might be a organized workplace area, neat and clean work environment, and structural, systematic, procedural way. And as well as if anyone enters to the factory or workplace, they can see the continuous improvement of all these four activities. That is called 5S. So one is what we implement is all the unwanted items or materials from the workplace. That is called oneness. Sairi. So sorting out wanted items is separate, unwanted items is separate. That is called oneness. So wanted items only we should keep it nearby the workplace. So what we have to do for unwanted items? So unwanted items we have to keep it in the red tag area. So for red tag team, they will revise the red tag card based on that. So what we have to take an action to evacuate the unwanted items from the red tag area. So this is called oneness. By implementing a oneness, we will get a lot of spaces. And coming to the second S, so the thumb rule is 30 seconds. So guys, can you tell me what will be the thumb rule of second S? If any stranger or any outside person, if they are coming into your workplace or in your workstation, so within how many time they can see the things, they can take the things, and they can replace the things very easily. So what would be the timing? What will be the timing of a 2S thumb rule? So if we implement a 2S in an effective way, we can see the item, we can take the item, we can replace the item without asking anyone. So what will be the timing of 2S set in order? Dear participants, can you make an interactive for this question? So what will be the 2S timing?
No idea.
Okay. So 30 seconds. The thumb rule is 30 seconds. So we will compare the 30 seconds with pH strip. Have you aware about the pH strip? Any chemical background people are here?
pH is nothing but to differentiate between the acid and the base material. 7 is the neutral point, I think. Is it correct?
Yes. And if we dip the pH strip into the chemical solution, what will happen is maximum 30 seconds, it will turn out into either red color or blue color. Am I right?
Yes, correct.
Yes. So red means what is the indication?
Repeat, sir. What is
Don't think it is a questioning session. So I want the session make it as an interactive way. So if it is red means what is the indication? What does it mean?
blue to red is an acid, sir.
Yes. Blue. If it is a blue.
Blue is automatically base, alkaline base.
Yes, exactly, sir, exactly. And red is acid.
Yes.
So like that, so if the stranger comes to your workplace, they can able to, like pH strip, they can able to see the things within a 30 second, take the things within a 30 second. replace the thing within a 30 seconds. That is called effective 2S implementation. So this 2S implementation contains 5 major activities like place allotment, marking, labeling, color coding, shadow boards. So by implementing all the FIFO, by implementing all these steps or activities, so the person, they can see the items, take and replace the items within a 30 second. That is a thumb rule of 2S, set in order. And third one, which is nothing but a shine, daily cleaning, autonomous maintenance check sheet. So nowadays, the employees or workers, they are doing a namesake autonomous maintenance check sheet. I'm not telling about the traditional autonomous maintenance check sheet. So there is an upgradation version of pictorial versions compared to the traditional check sheets. So the people, the companies, they are using well implemented lean companies, they are using a pictorial check sheets for the autonomous maintenance, preventive maintenance, as well as planned maintenance. So that is called a shine. So may I know what is CLIT? CLIT, CLIT. This is a terminology which we are using when it comes to a 3S implementation and TPM also. What is CLIT? CLIT, CLIT.
Was cleaning, lubrication,
Yes,
inspection,
yes.
and tightening.
Very good. Well said. What's your name?
Prem Kumar.
Prem Kumar. Yes, well said. So when it comes to a TPM implementation or a 3S implementation, the employees, if we say to an employee to clean your workplace, means he or she is supposed to do this CLIT activity. First is cleaning, and second one is lubrication between the joint areas, as well as inspection whether there is a physical cracks or any abnormalities. Then tighten fasteners like screw, bolts, and nuts. So this is called a CLIT activity. This has to be done when we implement the 3S in our workplace. And 4S, which is nothing but a standardization. So following all the 3 S's in a regular way, in a daily routine, checklist, by implementing a checklist, color codings, visual management board. Visual management board, I'll show you a one company implemented visual management board. So we implemented 5S there. So we made a customized visual management board for them. So I'll show it to you. And the final one is sustainable activities. So if the process or if the system is getting successful, means there might be a continuous improvement and of the activities or the process. So by following the 5S auditing in a weekly basis, not in a monthly basis, weekly basis, the employees, they will get aware about this 5S activities. And if we provide a proper rewards and recognition system in terms of 5S to the employees, it will give the motivation to follow the 5S activities. If the company is running under the 5S, which means there is a no unwanted or clumsy workplace, neat and organized workplace, clean work environment, systematic and procedural way of their core process, and continuous improvement. So this all benefits the company will get once the 5S is being implemented. So this is the outline, and this is the one leather industry outcome of 5S implemented due to the NDA. So I cannot share the before and after video of the companies. So here it is. I have mentioned the outcome of 5S implementation. After the 1S implementation, they got 2,360 square feet spaces got saved. And after the effective 2S implementation, the 3 manpower got saved in warehouse. Searching time of employees have been reduced in material store, warehouses, production area, and office areas as well. And the third thing is breakdown maintenance problem got reduced, and still it has been in progress 3S implementation. And 4S, 5S also in pipeline of implementation progress. So this is the outcome of a 5S implemented company. So this is the visual management board. So it contains a zone details. Will be the zone members, zone leader, sub-zone leaders, and likewise, what are the 5S activities they are taking care of each and every day basis, routine basis, and weekly audit details will be displayed here, and audit NCs also, closure details also will be displayed here, and best performance of the employees. So 5S, in terms of 5S, so from each and every zone, they will display a best performance performance of the employees on a monthly basis. And in terms of 5S, if they implement anything, if they have done any improvement means, that is also, that category will be different. Best practices. So monthly 3 members, they will be getting in terms of best practices and best performance, rewards and awards. And this 5S is indicating their status of their zone status about a 5S implementation. If in case a 1S is implemented, there is no unwanted item means today date is 29. So on 29 May, a zone leader, they supposed to do a hatching. If it is a zone is good, above expectation means they have to hatch it in a green color. And if the zone is not up to the mark, they have 1 or 2 NCs means internal auditing while doing an internal audit. So they will hatch blue color. And likewise, if the zone is worst, there is a lot of NCs means they will hatch it into a red color. So this is the visual management board, and right side you can see the zone improvements. What are the improvements they have done from the initial stage, like 1S, 2S, 3S, 4S, like that, they will be displaying in the right side of the visual management board. So this is what the example of 5S visual management board. If we implement this 5S visual management board in a workplace, in a work area or in a zone, what will happen is your customers, when they are coming into your factory, they will see without explaining, without effort of explanation. So the outsiders, they can easily understand what is happening in the workplace. So it will fostering about the company culture also. And so value stream mapping. So likewise, like 5S implementation. So the Foundry industry, if they are doing a value stream mapping, they can save the money in an effective way. For example, I have given here as a layout of casting department and raw material receipt, melting and furnace operation, molding and core making, pouring and cooling operation, shakeout and cleaning, quality inspection and dispatch. Why I have mentioned here a black color as a non-value added activity is raw material receipt itself, the cycle time is around 4 hours. So it's absolutely a time killing process. So we have to align it. We have to focus on raw material receipt cycle time reduction process. And while shakeout and cleaning process also, there is no physical changes in the product, right? So we have to reduce the timing for shakeout cleaning process. And quality inspection, it will be like if I tell you a sentence, it will make a big debate. Quality also, it is a non-valued activity. You believe me, quality is a non-value-added activity. Why I'm saying quality is a non-value-added activity? Can anyone explain? Can you please anyone explain about why I'm saying quality department or inspection process is a non-valid activity?
In
It
quality,
checks
just
only okay and not okay. It is not adding any value in product.
Yeah, yes, that is exactly. So what's your name? What's your name, sir?
Sir, this is Gopalakrishnan, sir, from IIF.
Okay, yeah, exactly, sir. Exactly. That's a well said. So quality, as I said, there is no changes happening. The person seeing a product, it is okay, it is not okay, right? So if he's doing a small correction also, that is a non-valid activity. So by implementing a value stream mapping also, we can reduce the lead time of whole process from 42 days to 18 days. This is an example for an understanding. And value add term from 12% to it will increase at 38%. And WIP inventory also will be getting reduced from 85 lakhs to 28 lakhs, and on-time delivery also will increase 72% to 94% if we implement a value stream mapping in an effective way. So if we dive deeper into the value stream mapping, then again it will take a whole 1 day to understand the step-by-step process, how we can implement the VSM. So this is the outline of understanding, and this is there is a scope of implementing a value stream mapping also in Foundry industry. And TPM and OEE, basically the average performing Foundry industry, the OEE, overall equipment efficiency, will be around 52 to 58%. If the lean foundry, if they are performing OEE around 75 to 80%, that is a very good and lean implemented foundry industry. If it is a OEE of the foundry is beyond 85%, means that is a world-class lean foundry. So how we can calculate the OEE is you may aware about this availability, performance, and then quality. So by following this OEE criteria, we can improve our foundry operations. So below I have mentioned the one case study. So from TPM pillar impact. So Patel Casting Limited in Rajkot, they have improved a OEE from 54% to 79% in 14 months through a proper planned maintenance in furnace. So their annual energy saving is around 42 lakhs. So by implementing any process, like if it is a 5S, if it is a lean 8 waste elimination, or TPM implementation, or value stream mapping in an effective way, we can see the visible result in our industry. So this is the inventory wastages example. Like raw material inventory is around 8 crore per year, and WIP inventory is around 5 crore, and finished goods inventory is around 7 crore. So the total inventory of the industry is 20 crore inventory. So the industry benchmark is a lean foundry should operate a 45 days inventory, but most of the foundries, they are operating a 95 days inventory. So excess inventory is from this value calculated approximately 10 crore. So the interest plus carrying cost around 18% is annual cost. Because if we store a material or parts or finished goods in a one place, it will not only capital amount blocked. So it is involving the carrying cost also, and as well as the interest. So if we consider the interest and carrying cost, the annual loss would be 10 crore multiplication of 18%. If we convert 18% into a number, a 0.18. So that is around a 1.8 crore per year. So because of the inventory, the company is losing a money 1.8 crore per year. So if we reduce the inventory cost, so the foundry, they will get a easier cash flow, effective cash flow, right? So then like this, furnace time, like waiting time, furnace capacity is, this is an example, like furnace capacity is 5 ton. So 8, they are doing 8 times of heating per day, and idle time per heat is around 35 minutes. So total daily idle time is 35 minutes. Multiplication of 8 heats is around 280 minutes per day, which means 4.6 hours per day they are wasting, or I mean the idle time, the furnace idle time is 4.67 hours a day. So imagine if the furnace, if the furnace is around 4.6 hours waiting or idle time, means what would be the OEE of this industry? So the cost of idle furnace, this is also an example, 18,000 rupees per hour. So the annual cost, if we calculate the furnace idle time, so 4.67 hours multiplication of 18,000 rupees multiplication of 300 minutes. So what will happen is 2.52 crore per year will be loss amount for the only idle time of the furnace. So this is an example. So if we are not implementing a lean in an effective way, these are the loss we will get. We will get it. Right? And third core tool is Kaizen. Most of the companies, they are not even considering suggestions from the lower level people. So for that, we will make a system by a Kaizen system. So Kaizen, which is nothing but a daily improvement, small improvement, it will make a big impact. So we will make a system like lower level for lower level people, middle level people, for higher level people. So hierarchy wise, we will split it into a Kaizen target number, and if we collect the suggestions from the workers level and the middle level and the higher level management, so by implementing a root cause analysis, if it is a defect is getting high, so by implementing a root cause analysis 5Y, A3, 8D methodology, so we can solve the defect wastages. And by starting a Kaizen activities in a simple way, like 5S, in terms of 5S implementation, POCOIO case, so layout changes like that. So we will get a lot of real-time Kaizens. And real-time case studies like Tata Metallics in Kharagpur, pig iron industry, their challenges were high rejection rate, 8.2% in pig iron casting. Excessive melt loss were happened. So furnace OE also 61%. So scrap cost is around 380 lakhs per year. So after the implementation of VSM, TPM, 5S, Kanban, their result, you can see the result here. In 18 months, the rejection rate will be reduced from 8.2% to 2.1%, and melt loss is around minus 1.8%, and OEE they were increased 61% to 81%. So this is the real case study of a foundry industry the successful implementation of this lean tool. Then Bongfili gearbox casting industry. So they have implemented a SMED, single minute exchange time. So before your die changeover time, so 240 minutes, and after the SMED, 38 minutes. So around 84% got in changed. Result got changed. And changeover per shift 2 times to 6 times. Capacity utilization around 59% to 83%. So they are implemented both foreign as well as Indian plant. So see, by implementing this SMED lean tool, what is the drastic changes in terms of KPI, cycle time, scrap values reduced, manpower utilization also increased, capacity utilization also increased. So this is the effective implementation of Bongfili gearbox casting. So what will be your implementing roadmap is, I'm suggesting you to split it into 4 phases. So one is assess and align. So I will share you a one lean assessment check sheet with Gopal sir. So he will share it with you. The assessment.
Hello. Sir, all of you wait for 5 minutes, sir. 2, 3 minutes, sir. He will rejoin. Dr. Ilan.
Participants, can you hear my voice now?
Yes, sir. Yes, sir. You can proceed, sir.
Yes. Sorry for the inconvenience. So I will give you, and at the end of the session, I will give you a lean assessment check sheet. So in your industry, I'll suggest 4 phases of the lean implementation part. So one is assess and align. So before the implementation, you should know what is the weightage of your workplace in terms of lean. So I'll share the lean check sheet with Mr. Gopal sir, so that he might share with you all. And second phase is quick win. Start your implementation in a incremental way. Starts from 5S, starts from SMED, starts from like low hanging fruits, like quick win. So it will not take much effort, like we could say low effort, low impact. Sorry, low effort, high impact. So like that, so you can take a 5S implementation or SMED implementations. Then third phase is scale and sustain. So whatever you have implemented in your workplace, like 5S or Kaizen or SMED process, sustain all this process in your workplace and implement along with the implementations TPM, start doing the Kanban and pull system activities also. Then final phase is streamlining about your strategic planning activities to align your organization goal with your work and implement the AI and ML implementations, like AI lean in industry 4.0. So casting industries, in casting industries. So why Foundry lean programs fails in the Foundry industry, in industry is, so the higher level management, they are not visibly committed and they are not visibly see the progress of your lean implementations. So by start with the 5S implementation, they will also get the confident from the process and copying the Toyota without any context, like uh, each and every places there might be a specific requirement of lean implementations. So for example, strategical process control for melt chemistry, 5S is for odd zones, like that. If you can classify it, you will see the result. And training without doing, like Kaizen events, definitely it will take 30 days of training. Deploy the concept of the Kaizen to your all the workers. So then they will also get a effective understanding about the process and ignoring the middle layer or lower layer. Like from the employees, most of the companies, they will not get the suggestions or ideas. So if the supervisors or in charges, they will get the uh, implementation suggestion ideas from the employees level, it will give the cultural improvement from the bottom level to top level. And no sustainable system, like there might be a audit frequency of the audit each and every week wise, and the visual boards to be implemented in your workplace so that the system will get sustained. So this is what the reasons why the lean program is failing in the foundry industry. And the final topic is a digital lean and industry 4.0. So digital lean means after the successful completion of lean implementation, we have to step into the digital lean. I mean, industry 4.0. So by implementing IoT sensors, so on furnace, real-time temperature, we can monitor the real-time temperature by using the IoT sensors. In furnace also, melt composition, we will get the exact proportion. And definitely by implementing this IoT sensors and on furnace, it will prevent the quality defects. And digitally, overall equipment efficiency dashboard. So it will give the live visibility of your availability. If in case in your workplace, if somebody or getting delayed in the workplace means, you will get the visible result, visible OEE result in each and every hour. And then AI defect detections, like camera, AI integrated camera, if we implement in the short blasting process or finishing line, so it will detect the porosity misruns in the process. And ERP integrated Kanban system. If in case like well implemented, lean implemented warehouses, they are following this system, ERP integrated Kanban. For example, everything is integrated by AI. So if the material is out of a number, so running out of the stock means it will automatically give you the signal to the purchase team. It will make a order to the supplier without human intervention. So that is called ERP integrated Kanban. So we could say this is a auto replenishment and predictive maintenance AI. So in Kanchipuram, one company, they are running completely a dark factory. So it is a electronic transducer manufacturing company. So they are using this kind of AI and ML implementations through machine learning. They will fix the IoT sensors and MLC formats on the furnace and molding machines. They will predict there is a possibility to predict the failures within a 3-4 days before. So that is a power of predictive maintenance in artificial intelligence and digital hand system. So you know very well about the hand system, if I'm not wrong. So there is an instant alert if the machine has got breakdown or if it got any abnormalities, means the machine will give you a signal like 3 lights. So in each and every machine, we can see the 3 lights like yellow light, green and red. So that is called Anden system. So we can connect that Anden system in a digital way. So it will reduce the maintenance scope. I mean, time of the repair or their process. So this is what the final stage of the lean implementation. So this is the advanced phase. In AI ML also, there is a scope of implementation in casting industry. So this is what the about the in industry. Yes. So as I told you, like Foundry is done by working harder. They become profitable by eliminating the waste in a systematical way. So I hope this session has given you a good insights and improve the implementations. So any questions, any queries about this topic? So if you want any clarification or if you have any doubt means, so you can please ask me. Dear participants, so if you have any doubts or any queries, so you can ask me. I'll clarify you.
Anybody having any questions? Anand sir, I think they don't have any questions.
Okay, so sure.
If they have any
So-
questions, I will send them to you, sir.
Sure. And I will show you a lean assessment check sheet here, so that you can get some idea. I hope you all my screen is visible, the lean check sheet. So this is the index page and the assessment for I told you, right? So in terms of 5S, in terms of value stream mapping, in terms of TPM, in terms of quality management, defects elimination, so PPS. So you can assess your workplace so that you can see the dashboard here. Like the scores will be displayed here. Okay, so if your score, you will get, for example, 0 to 24% means there is no lean evidence. We have to initiate the lean implementation process. If it is 25 to 49% means, so they are getting aware about the lean concept, but there is a lack of sustainability. And if you are getting 50 to 65% means there is a specific output, but that is not a consistent manner. And 85%, 68 to 85% means that is a well implemented. And if you will get 85 to 100%, that is a benchmark Foundry industry. So I will share this check sheet with Gopal sir. So you will get the check sheet from him. Do the assessment. And if you have any doubt, you can connect with me. So I'll clarify you.
I think it is a vote of thanks time. Good evening to all respected dignitaries, office bearers of Institute of Indian Foundryman, and esteemed speaker, industry professionals, and participants. As we came to the end of today's highly informative and engaging webinar on unlocking the lean potential in foundry industry, it is my privilege to propose vote of thanks. First and foremost, on behalf of National Center for Skill Development, I express our sincere gratitude to our distinguished speaker, Mr. Anand S., founder, CEO of Bubbles Management Services, for delivering such an insightful and practical sessions. Your deep knowledge and valuable experience in lean manufacturing, Kaizen, TPM, Six Sigma, design thinking, and problem-solving methodologies have provided all of us with meaningful learning and actionable ideas for implementation in the foundry industry. Your practical examples and industry-oriented approach made the session highly relevant and impactful. We extend our heartfelt thanks to our mentor, Mr. Narasimhan sir, and Chairman, Mr. K. Dayalan sir, and Co-Chairman, Mr. C. Satyanan Teacher sir, for their continuous guidance, encouragement, and support in organizing these valuable programs successfully. Our sincere appreciation also goes to all NCSD committee members and organizers who worked behind the scenes to coordinate and conduct these webinars smoothly. A special vote of thanks to participants who joined the session with great enthusiasm and active involvement. Your presence and interaction truly made this program successful and meaningful. We hope today's session has inspired everyone to adapt lean practices and continuous improvement initiatives for achieving greater efficiency, productivity, and competitiveness in the foundry sector. Once again, I thank you all for valuable time and participation, wishing everyone's continued success, good health, and professional growth. Thank you and have a wonderful day. Thank you. Thank you all for attending the session, sir.
Thank you.
Anand,
Thank you.
sir.
Yeah. Thank you so much, sir. Thank you so much.
Thank you so much, sir.